Hello to the viewers watching this. I welcome you all to this video presentation. I am Nayab Hussain, a PhD research scholar working in the Department of Chemical Sciences at Tezpur University. First of all, I would like to take the opportunity to thank the Standing Research and Innovation Committee of Tezpur University for approving our project. We are really grateful for that. Now, without any further ado, I would like to start the presentation on the proposed project work. Here you go. That the body metabolism produces different byproducts which are called to be the metabolic waste, like different salts, phosphates, sulfates, even nitrogenous waste. And one among those nitrogenous waste is the creatinine produced by the muscles. Now, so to check if the person is having a renal dysfunction, if the person's kidney functioning is proper or not, the concentration of creatinine is a direct reference to that. And the traditional method that has been used for the detection of creatinine is based on a colorimetric method proposed by Jaffe and is called as the JS method. However, this traditional method of creatinine detection is not free from limitations and drawbacks. Some of the limitation drawbacks are mentioned here, such as it requires a sizable amount of blood, and the results are interfered by the blood component, by other blood components such as glucose, ascorbic acid, uric acid, proteins, etc. In fact, false results have been obtained in cases of patients who have already been under antibiotic treatments. Then again, since this detection method is a colorimetric detection method, the colorimetric or the UV visible setup cannot be miniaturized. Extra chemicals are required for the test. And it is also noticed that the analysis results varies from laboratory to laboratory, indicating that the physiological condition of the environment also plays a role in the detection. Hence, meeting these limitations or tackling these drawbacks have been a challenge that has found great interest in the field of researches. Here is a plan of our work. We'll be taking salts of different transition metals such as cobalt, nickel, copper, manganese, and cadmium, and their electrochemical interactions with creatinine will be studied. The electrochemical studies will be carried out by cyclic voltammetry, chronoamperometry, linear sweep voltammetry, and differential pulse voltammetry. Since it has been reported that the complexation of creatinine with the transition metals are highly dependent on the pH and the solvent system, we'll be studying the interaction of transition metals with creatinine by varying these physiological parameters of pH and solvent system. The electrochemical responses will not just be studied for bare electrode but also for modified electrode. Electrode modification will be done by metal deposition on working electrode and by using other advanced materials such as multi-walled carbon nanotube, graphene oxide, polypyrrole, and ordered pyrolytic graphite. Hereby, we are sharing some preliminary findings. As we meanwhile plot a graph of the inhibition percentage of the oxidation peak of pure copper sulfate by various strengths of creatinine versus the strength of the creatinine, we get a curve. We get a logarithmic curve, as you can see in the picture. This graph is the inhibition pattern of the oxidation peak of copper sulfate by various strengths of creatinine. So here is the conclusion of our preliminary findings. The trend has been encouraging for us because the variation in the electrochemical responses of copper sulfate by the presence of creatinine has been well established. There is a further analysis will be done to determine the response time, sensitivity, and selectivity of each of the system to make a comparative study and realize the best reaction system for sensor fabrication and miniaturization. The ultimate goal of our project work is to fabricate a handheld POCT device because in a country like ours where 70 to 80% of the population lives in rural area and they do not have the easy access to creatinine detection facility. So in that case, a POCT, a handheld device, can be of great help in quickly monitoring their health status and give an easy access to the health facilities. So with this, I would like to wind up the presentation. Thank you very much for listening.